Alright, so I am really late with these videos. I've had a really busy week. I'm gonna try and catch up. Alright, so day 3, a few days late. You descend a short staircase into the surprisingly vast lobby and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each of them have a red light above it. They're all offline. Sorry about that, an elf apologizes as she tinkers with a nearby control panel. Some kind of electrical surge seems to have fried them. I'll try to get them back online soon. You explain your need to get further underground. Well, you could at least take the escalator down to the printing department. Not that you'd get much further than that without the elevators working. That is, you could if they were, one or so offline. Okay, there are batteries nearby that can supply emergency power to the escalator for just such an occasion. The batteries are each labeled with their joltage rating, value from 1 to 9. You make a note of their joltage rating, your puzzle input. So here's our example. The batteries are arranged into banks. Each line of digits in your input corresponds to a single bank of batteries. Within each bank, you need to turn turn on exactly 2 batteries. The joltage is equal to the number formed by the digits on the batteries you've turned on. For example, if you have this line and you turn on 2 and 4, you get 24. Yep. You cannot rearrange them. You'll need to find the largest possible joltage each bank can produce in the above example. So 9, 8, 8, 9, 7, 8, 9, 2. Okay, so this problem So basically we're finding the largest numbers with some direction. So for example, let's look bottom here. We find the largest number in the entire thing, 9. And then we have to find the largest number to the right of it, so 2. It's the same here. So if we go here, find the largest number, 8. Oh, hold on, 8. There's nothing to the right of. Oh, that's actually not. Oh, that's a weird edge case. There's a weird edge case here as well. So basically, the edge case, if you don't have anything to your right. Oh, I hate that. Actually, I want to focus on this one first because I think it's easier. Or like this type of thing. So we will think about that edge case. And for today, we're using Ocaml. So I wrote a little, just like some basically boilerplate to read our lines. Here we have read lines, which pipes a list of strings. So it's like each line. So okay, I'm gonna start by only solving the problem partially. By starting this bit here. Let's copy these. Okay, so now what I'm gonna do is I'm going to find the largest number in the list, and I'm going to remove it and everything to the left, and then find the second largest. Okay. Solve line equals so we have, let's take a list of integers. I think it's easier. So let's say, line is a list of integers. Ocaml is magical, so I don't need any type annotation. So we go list dot highest. Let's go another one, which is let's get rid of that. Highest number on a list, which is list.fold left, find the accumulator, the item. If I is bigger than accumulator, then I else is C, and you take in the accumulator first and the list. Okay. get highest number and index. So actually accumulator is going to be a little bit, you know, special. In this sense, because it's going to have an index. And we go I, index plus 1, index plus 1. If this, I'm just trying to tidy this up. I have no idea how to write like legible Ocaml. We return index. Oh no, we only want to we only want to keep the index here. The index. So I mean, we want the index of the list, but also the index of this number. Let's make like highest and then highest index. I is bigger than highest. We return I and then index. Okay, so that's always index plus 1. It will always just continue. This actually goes there and like this, like quite nice. So now here we go. Just highest and then highest index. Okay, I think that makes sense. So let's actually go and like, let's take like line first line equals list.nth. Is it taking a list or a number first? List. And we go like let highest and then the highest index. Oh, but we need to convert. So let's go like let string to int list. List dot no. So there's some string utility, string dot to sequence. L into this into into what? Into, so now we have a char list dot from sec to of sequence, and we go for each one. And we go and pipe that list into list.fold left on ACC. The item, we go int of char, and this is actually going to be a little bit annoying because we need ASCII Ocaml get ASCII of char. Char.ascii. So we get a character. Now hold on, int of char returns the ASCII code of the argument. So this is actually going to be a little bit strange. So int of char I. Why is this not right? So fold left ACC empty and then list, and then it returns ACC. Yeah. Okay, string to sequence and then fold. Oh, I got two of them. And yeah, okay, but now actually we need to go and minus, or actually just minus the int of char 0, I think, is equal to first line into string to int list to get highest number of index. And here we go. Let's actually cheat and use this for what it's not intended for. What do you think part 1 is? Oh, yeah, well done. Highest index. There's probably a nice way of doing this. Now we return highest and highest, or like, let's go T, let's just call it T. Yeah, okay, that's nice. That's working, I think. 9 and 14. Oh, index, yeah. 9 and 14. Which one are we doing? 0. So 9. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think we kind of just should be 0, right? Yeah, okay. It's because we're, wait, hold on, maybe we can. Oh no, if we fold right, it's gonna break a few things now. Let's try. Fold right doesn't do the same thing. Okay, so let's just list.rev, the list there. Okay, cool. 9 and position 0. That's kind of what we expect now. Great. So let's try with line 1. Let's go to position 14. That's right. Let's go line 3. 0, 1, 2, 3, 4, 5, 6. Okay, good. So that's all working. Basically, now what we need to do is we go let let's go highest 2 with a list. So we go let highest and highest index equal get highest there. Okay, so then we go let remaining list equals sorry, fine. Sorry. Okay, we have this, and now we get list dot split transforms a list of pairs. No, list dot slice Ocaml slice list at index. Are you serious? I can't actually do this or something, can I? Ah, I love this language. This language is fun, but like it's so weird. Like it'd be one operation, because I guess lists can, their length is not really known. So let's just go like slice at index L equals let recursive loop We're just gonna count, I guess. Index match it with accumulation is going to be like the list. So if it's empty, then it's going to raise. It's going to be like raise gone too far. Then head or tail. Let's go like current. Let's go I and then like actually CC. And we go here. If I is equal to index, then just return tail, else loop with I plus 1 and tail. Raise, really input string. God, this is all horrible. I just want to fail with. Okay, fail with too far. The head is kind of lost here because we don't care anymore. Else this. Your loop 0 and L, right? This should just return, yeah, another list. So let's remaining list equals this might give me off by 1 errors. Highest index. Second highest, and we don't really care about the index. It's going to be get the highest of the remaining list, and then we return this, and let's go and get second highest here. And we pipe it into all this, and then we go highest 2. Second highest, 9, 9. Okay, so I think we're off by 1. Then tail. Ah, no. Okay. Oh, okay, yeah. So this is list 3 here. 9, 2. Yeah, so I had to reverse the list. Yeah, because we're, yeah. Okay. Now we still haven't solved that one edge case, where like if it's to the right, but we will solve it, and we can solve it here. So next thing is if we do which one? I think, well, 1 will work, right? So 0, 9, 8, yeah. Go here, we will get a 9, 0, because it will go 9 and there's nothing to the right. And actually, I don't know, should probably fail. Let's go if highest index is equal to the length of the list. Then actually, we're gonna slice at index. If is equal to list of length of L, then actually the slicing index. Oh no, we just want to crop the last item. Remove the last item. Is there a list.pop? Ocaml list.pop or something. Mate, I just want to remove the first item. Okay, I'll remove first element from list. Remove the first element of a list. Okay, yeah, so there's this like, okay, so yeah, oh yeah, that's nice actually. It's quite neat. Function, I don't know what this is here. Function, I don't know what the function keyword is. It's interesting. Then we actually go and we do cut L, else L. This is actually going to be the list to slice. Too far. Highest index plus 1 is equal to that, and we cut L. And we slice. Oh, actually, no, sorry. Yeah, okay, got it. Cut the first item. I think we gotta reverse and then reverse again or something. Okay, so actually here, I think what we should do is take this. If then else, because otherwise if it's this, then we actually just want to cut L. Okay, 9, 8. Nine, 8. Okay, so actually this is a little bit wrong. It's part 1 we get 9. Oh wait, no, this is really wrong. Fuck, it's really wrong. Because, yeah, it's not taking into account something, like it's just gonna go do 9 as the highest. 9 actually can't be the highest because it doesn't have enough. So basically on the first way round, what if we just cut the last bit and we go, actually we need the highest from here. Yeah, I think that would work. We remove the first part. List without last item equals cut from L. I think we actually need to reverse this. Start reverse. and then reverse again. Oh, we are going to need slice at index. Oh wait, hold on. I've removed something I shouldn't have. So we're going to remove at index from list that last item, and then we get the highest. The remaining list is actually this plus. It's interesting because like if we don't remove the last, oh no, this is fine. It stays the same. 9, okay, not ideal. Here's highest and second highest, okay. I need like a print function. Apparently I can do this. I don't know what this is, but we go print in line, int of char or string of int, print list with a tail. What's going on here? Maybe I need to do this, and I don't know why this happens, to be honest. And let's go in loop. Oh. I guess. Actually, just print int here. We can remove that there. 9 1 1 1 1 1 1. Okay, this is not super useful, I guess. Let's just start by doing Ocaml. Okay, we definitely do want to reverse, but then we want to reverse back. Okay. No, wait. We want to remove the last item. So we cut we reversed. Wait, we reversed and we got this. Oh, it's because I think it's printing in like the wrong order or something. Okay. Okay, well, if we do that, that kind of works. Eight, 9. 9, 8, 8, 9. Is it gonna get 7, 8? I think it, yeah, I think it's actually working. I was just confused by the order. 7, 8, and then let's see, last one is 8, 9. Ooh, no? 9. Oh no, 9, 2. Yeah, no, it is 9, 2. It's not 8, 9. Nice. Nice. Okay, we have a working thing. So now we need to accumulate all that and add them together. So let nums list.fold left fun accumulate, which is a list, and then let's go with like with line. And we go, and we do first line, no, just line into string to int list into highest 2. With ACC, we give you this. We give you lines, we get rid of you. Now we have nums, such as this. And then we go, let part 1. Okay, we got there. It took us a while because I'm not super familiar with Ocaml, but we did get there. 0. Nums fun ACC left right, we go ACC plus left times 10 plus right fold equals fold left 3 5 7. Finally. Okay, let's make sure, let's see. Let's hope this is right. Nice, nice, okay. Okay, part 2. The escalator doesn't move. The elf explains that it probably needs more joltage to overcome the static friction. Stiction, nice. Of the system, and hits the big red joltage limit safety override button. You lose count of the number of times. She needs to confirm yes, I'm sure, and decorate the lobby a bit while you wait. Okay, now you need to make the largest joltage by turning on exactly 12 batteries within each bank. Oh, ew. Oh no. Oh no, I'm just thinking that my little, like, my hack for this part 1 is not gonna now work for part 2 very well. Oh no. Okay. So I mean, yeah. Okay. So for my part 1, I looked at the highest number, 9, I removed it from the list, and I continued. But basically, I also removed the very first item from the first time around. Oh, if we remove, we need 12. There's 15, right? So 15 minus. So we remove 3, find the highest. We remove 3, we find the highest. Oh, and it's a loop. I think that works. Think about it. We remove, instead of removing 1. Let's see. Can we make it make sense? So if we for part 1, we needed 2 numbers. We had 15, which is the length, and we remove 1. The reason is that we need 2 numbers out. Oh no, actually, we don't remove 3. We remove length minus numbers that we want, you think about for part 1, that would be 15 minus 2, 13, plus 1, because we want to get one number. So for this one, 15 plus 12, sorry, 15 minus 12, 3, 2, no, 15 minus 2, plus 1, no. We wanted two numbers. Basically, I'm trying to make it so that a little, like a small like formula to make it so the length of this minus the number of numbers we want, which for part 1 was 2, to give me 1. We wanted two numbers, so two numbers, and we want to find the first number, so we take away 1 and we get 1. So if we have 12, we take away 1, which because we want the 12th number, we get 11. So we remove 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And anywhere here, because that works, that actually works. So I'm actually going to refactor part 1 to use that highest n and an n there. And we're not just going to cut the last item. We're going to cut n items. And I'm going to just, I'm going to do L and an n. Yeah, this is great. This is going to be good. Okay, so let's match. Yeah, we want to cut a certain number, so. Yeah, we want to cut a certain number. Or actually, we can probably do this without reversing by appending to ACC until we've reached a certain number. So match index with, not this, this goes underneath. N. So true, we return ACC. False, we return, or actually, oops, this is actually way easier. If n is equal to n, then ACC, else loop. Oh no, but we still want to go through the list, right? Okay. Match ACC with empty list. We probably raise here actually, and then we go. Hold on, and then this slice at index, does that still work? I think it does work, yeah. And we go head, tail, if then we just return ACC, else we loop with head ACC, index +1, loop L0. So this takes in a list of integers and returns integer. Yep. So we want to cut n. We want to cut the last two. We want n minus 1. nums. Whoa, what's nums now? Yeah. This without the last item. I mean, what's this confused about? Okay. Oh, highest n needs to be there, so that I can then apply number 2 to this function and tail. Well, the accumulation, the index, and the actual list. And then tail there. Okay, well that's not right, but let's undo this, and let's just actually do this. 1.8. That's not right. Okay, so that means that something else is wrong. Print list without last item. I think it's probably just there. Ooh, that's not right. Let's just see if there's Ocaml remove last n items from a list. How to delete? No. Ocaml cap list to n items. First k is equal to 1, then this. Oh, this is nice actually. So yeah, we think about it differently. We actually go first n. We match the rest of the list. If k is 1, then we start with this. Oh no, it's just like that's the base case. Then we return first of n, k minus 1. I don't know what these are for. We want the first list.length of L minus, so 15 minus 2 plus 1. And this means it removed 9. But actually, we want to list.reverse and then list.reverse again. Maybe not list.reverse again. 1 1 1 1 1 1 1 1 1 1 1 1. Okay, so it is missing 1, and it did get. Oh, we got 9. What? Part 1 is not 9 1. Wait, what the hell? Why is it that? Why is it 91? It's not 91. Printing that, we're reversing, we're doing this correctly. I actually think maybe we don't want to reverse just the way that the other things are programmed. No, we probably do. Ah yeah, we want to reverse, but the printing is in the wrong order. Okay, so now 357. Okay. Does it just work, maybe? Curious. So now let's rename this nums part 1, nums part 2, part 2. Oh, and well, hold on, the accumulation is going to be quite different as well. Because it's going to have to be, well, it's going to have to be different. So let's actually figure that part out first. We need to times by its length on the like. Oh no! Oh, I have an idea. What if we join the tuples? What if we don't return tuples and we return? Oh, but no, this has to be different as well. We can't just do 2 times. We need to do n number of times. So basically, we go through list first, n items, but n will change, so so it's going to take in numbers, which is ACC, a list, and an n. So what we're going to do is we're probably going to match on n. Then we've reached the bottom. Otherwise, we basically do this entire thing. We got the first n of n there, and it's going to start at 2, and it's going to go to 1. And we don't do the second part. It's bound to there, okay. Highest in the highest index. Then the remaining list, we go loop highest with the ACC, and with the ACC, the remaining list, and n minus 1. We go loop and L, like so. Oh, int list of list. Oh, hold on. Int list. What are you? You take in an integer. Oh, yeah, you take in number of things we want and a list of integers, and we return you the list with the highest. Yeah, okay, that makes sense. So nums for part 1 is not very nicely applied, I guess. Oh no, that's right. Yeah, because it's each line has a list, right? So and there we go. Let's number from int list, number in the list, and we go this is gonna be super hacky, I think. no, let's do this properly. We can. But first, I actually want to comment this out. Well, that will change anyways. So we go print list, which is here. To 9 for the first one. 8, 9. 9, 8. Wait, how does it change if I do this? Huh? 90. Oh, because it's doing the last one. Okay. Yeah, that's fine. Okay. And now you'll see, well, actually I don't want this for now, because now I'm going to do num from int list and number. So we go, that's recursive loop, ACC, which is the total number that we're going to return, and a list. So, wait, what's n? We don't need n, do we? No, we don't, just L. So we go match L with, again, yeah, it's going to be syntactic. Like, I'm not writing this in fold lefts, which I can do, but I think it's a bit clearer. If it's an empty list, means we've run out of it, and we go just ACC. Head, tail, we go. We loop, the ACC is this, C plus index times the head, the index plus 1 and the tail, and we go 0 and, oh, actually 1 technically, right? Because, and this. Oh, yeah, so actually 0, the index, and the list. Mm-hmm. Right, well, that's not right. Two 9. Oh yeah, no, 2 9 makes sense, actually, it makes sense. So we need to add 2. Index is going to be 1 times the head, and then index plus 1. Why am I getting 0, man? Okay, accumulation 0. We get the head, we accumulate, so 0 plus the index, which is 1 times the head, which is going to be 2. Then we do this. So confused. Why? So if I make this 2, what happens? Why is it like this? No, hold on. That's printing 39. 31, what the guys, what's happening? ACC is 0, index is times the head 2. Oh yes, whoops. Yeah, that makes more sense. Got it. Yeah, I can't just. Okay. 92. Okay. Let's. Part 1 equals list.fold left. With all of that added together. The accumulator is 0. Okay, so now I should have AC properly. It doesn't have line actually. Properly. Yep. And now we go. Well, we got basically C plus. Actually, hold on. We should be able to do this with 0 of list.map a function. The function is going to be num from into list of part 1 357. Okay. Great. That works for part 1. Now let's change this so that we can do that. 3, 1, 2. Oh, it's close. It's close. It's so close, man. So it's okay. It's close, but it's not close enough. Let's do 3, and let's do only this one. The highest 3-digit number is 987. 978. Okay, so we have like an out of order thing we need to reverse somewhere else. When we go highest n, the remaining list needs to be reversed. Okay. 19. Oh, I think we have it, boys. Look how fast that was as well. Whew. Come on. Let's go. Whew. Okay, so that was Ocaml. This language always beats me up every time I pick it up. Like, look, the thing is, it's so nice to read and to write on. It's like it feels so clean and nice, but because I don't do it too often, like it just becomes like such a mental exercise to get back into. But it's really fun. I might do another puzzle in this, to my despair. I don't know how long this video was, probably an hour. But pretty cool. I like how the first part, I like how we refactored the first part to have like a generic algorithm, and now all you have to do is change this to be 12, and you have it. Yeah, there's probably way nicer ways of expressing these various things, but like a lot of stuff like this can be like a fold left for sure. Even stuff like this, like it's just because I'm not super familiar, so I don't really know what to expect too much. I'm going to get rid of these, and okay, yeah, we are done with day 3, and I'll catch you in the next one.